Kirk math. All right, ladies and gentlemen, here we are. We've made it. We are on the last lesson of topic 9, 9.7. We're in our student companion on page 216 to 217. In this lesson, we're going to learn about linear quadratic systems of equations. So if you remember, when we had just linear system of equations, we would have like 2 or more equations in this format, You would have 2 or more of them, and you had to graph them together and figure out where they met. And that's kind of what we're going to do here, except we're going to graph a linear equation and a quadratic equation, and we're looking for where the 2 meet. So let's dive on in and see how it goes. All right, so like I said, the beginning of this is just kind of identifying what is a linear quadratic system of equation and how do I find solutions of a linear quadratic system of equations. A linear quadratic system of equations includes one linear equation and one quadratic equation and is represented on a graph by their corresponding line and parabola. So when I have slope-intercept form, not always in that form, but when I have slope-intercept form, and if I have something in standard form of the quadratic equation, then I know I have a linear quadratic system. Here are some examples. So these purple lines on both of these graphs are representing the linear function in the system. And then each of these parabolas are representing a different situation that gives us different types of solutions with our linear equation. So if it's a green line, right, the green line is not crossing the x-axis, but it's also not touching our purple linear equation. So when the green and the parabola and the purple line do not intersect, we have no solution. So if you're taking notes, I would write that down. When the blue parabola is graphed, okay, it's a little bit bigger, you can see that it's only touching the purple line in one spot. Even over here, it doesn't look like that, but it's hard to tell, but this purple line is only touching my parabola in one spot. So one solution to my linear quadratic system of equations is when only one point is connecting where the blue parabola and purple line intersect. And then the last one we're looking at is this red or kind of orangish colored parabola. So when the parabola is large enough and our linear equation is crossing through the parabola in 2 locations, get rid of this. So when we are meeting in 2 locations, whether it is directly across or diagonal, you have 2 solutions. It's when 2 points of the red parabola and the purple line intersect. So overall, a linear quadratic system of equations, just like a quadratic equation, can have 0, 1, or 2 real solutions. And it all depends on the graph of where the linear equation and the parabola intersect. So our first example is graphing linear quadratic systems of equations. We're going to learn 3 different ways to solve these problems. We are going to learn graphing, which is what we're going to learn right now. We are going to learn elimination, and we're going to learn substitution. And this is very And this is very similar to linear systems of equations. We learn the same 3 formats, except now we're just combining a linear equation and a quadratic equation. So this is our try it. We're going to identify how many solutions does this system of equations have. This y equals x is my linear equation, and y equals x squared is my quadratic equation. Explain and use the tool to support your answer. So basically there is a graphing tool, and you might have a graph in your student companion you can use. But what we're going to do is we're going to fill in these tables, one with my linear equation and one with my quadratic equation. And I'm basically, because of the way that this is set up, it's super simple. I'm just going to plug in numbers for x and figure out what y is. We're going to talk about some other ways that you can solve or graph linear and quadratic equations because we have learned a lot of different ways. But for now, we're going to start just super basic because our equations are very basic. So I'm probably going to start off with the same numbers. -1, 0, 1, and 2. Let's just do these 4. Okay, and we're going to plug them into our equations for x. So my equation for my linear would become y equals -1. And what you'll probably start to notice for this one is that anything x equals is also what y equals, because y equals x. So if x is 0, then y is 0. If x is 1, then y is 1. If x is 2, then y is 2. And then we would graph this on a coordinate plane. So go ahead and start plugging in these numbers here for our quadratic equation and see if you can graph that parabola. And then in class, we'll talk about where our solutions are, because we're basically going to get a parabola, negative or positive, a line, negative or positive, and 1, 2, or 0 points that we then have to identify. So go ahead and finish the quadratic one, and then we'll talk about the answer in class. All right, in example 2, we're continuing to solve these problems and continuing to graph, but this time I have a linear and a quadratic equation kind of in one. So you'll notice here that in this equation, I have 2 x's and I have 2 constants, and we want to use this linear quadratic equation to solve. So what I'm basically going to do is just split this equation into 2 pieces. One of my sides, the one that has the square, is my quadratic function or equation, and the other side, which does not have x squared, is my linear equation. And so once you split the 2 in half, I can now use both of these equations to graph on a coordinate plane and find my solution. Now, there are lots of different ways to graph. So I just Googled this, and this is what Google, and I even think it was the AI version of Google, kind of came up with. So steps for graphing an equation using slope-intercept form, or slope and y-intercept. When I am given slope y-intercept when I'm given slope-intercept form, the first thing I'm going to do to graph is find b. That is my y-intercept, and I'm going to graph that first. So if I was graphing this, I would graph +3 first. Okay? Then I'm going to plot the y-intercept, which I did, and find the slope, which is m. Now my slope here is an invisible 1. So that means I'm going to go up 1 and over 1, and that's where my new point will be. Down 1 and back 1, and that's where my new point will be. And so if I was roughly sketching this graph, I'm going to get a line kind of like this. Okay? You're making these single steps and rising and runs and connecting the points within your line. That is how to graph, as a reminder, how to graph a linear equation. Now we also need reminding how to graph a quadratic equation. So here is the AI overview of some ways to graph quadratic equations. And you might notice that there's a lot of them, and there were probably even more. We have learned a lot of ways to do this. You can use any of the ways that we have learned in this topic and the last topic to graph these quadratic equations. So one of the ways to do it would be to complete the square. Okay, another way might be to find the intercepts of the parabola. Another way might be to use the square root if it's a perfect square and factor. Another way might be to use the discriminant and figure out how many solutions you have. Another way might be finding the roots by factoring, even if it's not a perfect square. Another way would be just to create a table of values like we just did on this previous example up there. Another way would be to use the quadratic formula, which you just learned in the last lesson. So you can use any of these ways to solve, okay? On the next page, we're going to go through one way to solve. It may not be the way that you would pick, but it's going to be the way that I'm going to show you. So you can check it out. So you could use a lot of different ways to solve this problem, but what I would probably do is, because it's not really set up in vertex form, and it's not really set up in standard form, there's no b, and it's not really set up in a factored form, I would probably just make a table. It's a really small quadratic equation, so I could easily pick an x and plug it in. So I went with our typical numbers, -2, -1, 0, 1, and 2, and I plugged them into the equation. And you'll notice that I started to, the values of my function started to increase and then decrease. So that tells me that 0, 5 is probably my vertex. So I would probably graph 0, 5, and then I would graph my other points alongside, and it would start to make the parabola, and then I could tell where my parabola and my linear equation meet. When I do that, I get this equation right here. Okay, so I'm right, 0, 5 is my vertex for that parabola, and when I graph my line and my quadratic equation, I find that both graphs pass through the point -2, 1 and 1, 4. So those are my two solutions, 1, 4 and -2, 1. Now the blue is highlighted here. This is the first point is in a different color because remember the answers to my quadratic equations are my x's. So these are kind of my x values. And then the points where they intersect show me the answers to both equations. So we're going to give this another try. So you can see that I split the equation into two equations. I have my quadratic equation and my linear. My linear equation, I graphed my y-intercept, which is 0, 3, and then I did my slope, which is a rise of 1, run of 1, and I'm kind of just sketching it out, but that's my linear equation. Over here, I made another table for my quadratic equation, because again, it doesn't really show a specific form, and it's pretty small, so I think it's easy to just kind of plug in our numbers and go. I found that my vertex is 0 and 1, and then I started plotting other points. You can see that about here at about -1, 2 is where they meet. And then we would have some point over here if I did the right side properly. Now, obviously, I don't have an awesome graph to do this on. I'm hoping in your student companions you do, but if not, you could use graph paper and graph it more accurately. In the end, you would get this right here. So here's my solutions. And yes, we were right with -1, 2. And then the other interception would be x is 2. And that's kind of how you do it. So go ahead and try with this one right here. It's number 2 in your try it, example 2, and tell us what you get. Now in this example right here, the next thing we're doing is learning how to solve the systems without graphing, but instead using elimination. And if you remember, elimination is when I use one of the equations to subtract from the other equation and eliminate a variable so that I can solve. So here they subtract the linear equation from the quadratic equation. That eliminates my y's, and now I'm left with something that I can factor and solve. Okay, so step 1 is use subtraction to eliminate a variable in the systems of equations. Step 2 is then to substitute the values that you get into your original equations. So if I go back, we're substituting into the linear equation. And that will help us find y. And then step 3 is we just check our answers. So the solutions they got was 6, 8, and 2, 0. So they're going to check their work and make sure they got it done correctly. So let's go ahead and try that here with elimination on this side. So what I did was I expanded the quadratic equation, making b the value of 0. I set up the linear equation underneath and subtracted. Now remember, this subtraction sign is applying. It's almost like distributing to every term inside. So this is really -2 minus 4. 0 minus -1. And then x squared has nothing to take away. Then I factored this trinomial and got my x values. Step 2 was then to substitute those x values into the linear equation that we didn't originally use, that we subtracted. And I got 7 and 2, and then you could check your answers. These are my answers up here. Okay, that is substitution. So go ahead and see if you can solve using, elimination. See if you can solve using elimination here. Now the last example is using substitution. So with substitution, we are going to set these two equations equal to each other, substituting the y's for each other. That's going to look like this right here. And if you pause the video, you can kind of see how they solve and get their solutions here. They factor the binomial. Then same thing, we're going to plug our values back into the original equation and find our answers. go ahead and take a look at example 4, and we'll check in class.